For the second lesson on recursive functions, we're going to look at recursing over string data. We're going to call this recursion2.py. So the first thing we're going to do is we're going to write a function called explode. And it would look like this. If we said explode hello, our output would be hello with the space between each letter, kind of exploding it out and making it take up more space, just like that. So we start out def explode. Our parameter is word. The first thing we do is test to see if the word's length is less than or equal to 1. If it is, then we need to stop, so we return the word. Otherwise, we return the character at word sub 0 plus a space, or concatenated with a space, and then our recursive call. And to recurse over the rest of the word, in other words, we're going to start with hello, and then on the first recursive call, we want the word to be ELLO if we're doing hello, for an example. So to do that, we'll use 1 colon to get a slice starting at position 1 through the rest of the string. And therefore, as we recurse through the string, we'll eventually get to where there are no more letters left in the word. So let's write some quick code to test that. Print explode, and we'll just use hello as the example. So let's exit and save, and we'll run the program. And there's hello exploded. So that's our first example. Our second example, I'll put the example up here in the comments also. We're going to write a function called remove dupes, which stands for remove duplicates. And so if we give it a string like this, AABBCC, it will return ABC. So let's write that function next. It also has word as a parameter. First thing we do is check to see if the length of the word is less than or equal to 1. And if so, we return word. Then the next thing we have to do is check to see if the two adjacent letters are the same. So if word sub 0 is equal to word sub 1, then we want to return straight to a recursive call and take a slice starting at the next letter in the word. In other words, word 1 colon, just like we did in the example above. Otherwise, this means that the two adjacent letters are not the same. We want to return the letter at word sub 0 and then our recursive call to remove dupes. So let's give that one a shot. Print remove dupes, AABBB, CCCC, like so. So let's do, just for fun, let's take this, cut it out, put it right here. That way we can print the original word and then the word with duplicates removed. So let's exit and save. Let's clear the screen. So there's our original version and there's our final version. So as you can see, recursion can be performed on both numeric data and string data. Having shown you these examples of recursion, let me just warn you that in most cases, it's much faster and more efficient to write the solutions to these function problems using iterative methods, such as loops and for loops and while loops, those kinds of techniques. However, for some problems, such as factorial, the natural solution is a recursive solution, and because modern computing hardware and software systems are relatively fast, the recursive solution will seem as efficient, if not almost as efficient, as an iterative solution. But with that, we're going to leave recursion again until the exercises, and now we're ready to move to the next advanced topic in the next lesson.